Hello all, myself Akhila and I'm Assistant Professor of Department of Computer Science at Government College Kasaragod. Today we are here to discuss one of the important topic in operating system, that is multi-programming in operating system. So what basically multi-programming is? So we human being has a tendency to do multitasking, am I right? While watching TV, we eat, and while walking we listen to music. So we do different kinds of multitasking in our day-to-day life. So while using the computers also we have that tendency of doing multiple programs together. We may open a Word document to prepare a report, but at the same time we may be listening to a music playing by from the same computer. So we may be opening a Google Chrome web browser and we may be searching for something. Then we will return back to our Word document. We'll continue with the report. So we do multiple programs at the same time in the computers too. So multi-programming basically means executing more than one program at the same time. That is a simple definition. So we human beings have different organs to support in our multitasking. That is, we can eat with our hand and mouth, and but at the same time we can watch the TV with our eyes, and we can walk with our legs, and we can hear music with our ears. So we have different organs which supports different functionalities. So it's easy to do multitasking for us human beings. But computers has only one CPU, and this CPU should execute all the programs, and in most of the cases at the time CPU can execute only one program. So how does computer manage to execute multiple programs with a CPU which can execute only one program at a time? So that is what multi-programming is, executing more than one program at the same time. So how does a computer manage to do that? That is what we are going to see. So CPU has a hardware, it cannot do anything. So basically it requires the support of the operating system to do this multi-program. So we may be knowing that all the programs which we install in computer or which we save in our computer initially resides in the secondary storage devices such as hard disk or in SSDs nowadays. And if that program wants to get executed, that is if you want to open a Word file, that Word file should come to the main memory. Whichever program need to execute, that should come to the main memory from the secondary memory. And from the main memory, those programs which need to get executed will move to the CPU. So that is the path. And here you might be knowing what is secondary memories, what is main memories, and the only thing that you might not be knowing is the ready queue. So ready queue is basically a data structure which stores all the programs which requires the service of the CPU. So what you need to understand here is all the programs which are residing in the primary memory or our main memory need not need the service of the CPU all time. Only those programs which need the service of the CPU will move to the ready queue for the CPU and will wait there. Okay. So here I have taken two programs, Word file and an audio file. Okay, so these both programs need the support of the CPU for the execution. So both will move to the ready queue and will wait for the CPU. And CPU will use some different sort of algorithm to select which program they should give first priority. So suppose that CPU decided to take the Word file first, and it went to the CPU, and we got that Word application opened in our desktop, and then we may be typing some character into that Word document, but that character that should be displayed on the Word document or that should be typed in the Word document, we should type that using a keyboard, am I right? But keyboard is basically an IO device which is an electromechanical device and whose speed is very less compared to that of CPU. Okay, so if we type a character in the keyboard, it will take time to reach to the Word application. Okay, So now CPU is thinking that anyway, Word doesn't get its character from the keyboard, it will take time. So it is better if I am putting that Word application in some IO queue, I mean input output queue for the keyboard. And when the character is available, then Word applications can continue with the CPU. But until that time, CPU will put that Word document in an IO queue where it can wait for the character from the keyboard. So now basically the CPU is free because it has sent the Word file to the IO queue for the keyboard. And so CPU would like to execute the next program in the ready queue. So here we have only one waiting, that is an audio file. So CPU will take that and will start executing it. Means we will start playing the music and it will do that for 2 seconds. And what next CPU will do is CPU will take that audio file from its core execution and will put back that into the ready queue after 2 seconds. Because CPU has sent the Word file to the IO queue for the character, by that time Word file might have got the character. So Word file might have returned back to the ready queue and will be waiting for the CPU. And now CPU also sent back the audio file which it was executing to the ready queue by telling the audio file that I have to process another file, you just wait in the ready queue, I will come and get back. Then CPU will take the Word file and will execute it for some time. Then again, when it needs the second character, it will send again the file to the input output queue. Then CPU will be free once again. Then the CPU will take the audio file and this cycle will continue until the Word file or the audio file. Both of them are getting executed completely. So this is actually the way the operating system executes multiple programs together. So actually the programs are executing interleaved fashion, but we are getting a feeling that they are executing simultaneously because that switching of the programs in from the CPU and out of the CPU is actually happening in a fraction of seconds. So that is why we are getting a feeling that both are executing simultaneously. Okay. So this concludes the concept of multiprogram. Thank you so much for watching the video, and I think you really got the concept of multiprogramming, and thank you.